This is a very interesting question, and I hope you're watching this video because this question can appear in a structured question also. So uh, the action here is to pump out air from the chamber, and you're asked what happens to the pressure within the bell jar and also within the balloon. So the answer to this question is both the pressures will decrease, and this is my trail of thoughts. Number one, when we pump air out of the jar, the number of air particles in the jar will decrease naturally. And when the number of air particles decrease, the chances and the frequency of collision by these air particles on the outer wall of the balloon will decrease. When you have lesser particles, the frequency of collision will decrease. And we're talking about the collision of the particles on the balloon by the air in the jar. So therefore, this gets us our first answer, that the pressure by air in the chamber on the outer wall of the balloon will decrease, because when the frequency of collision decrease, the total force acting on the outer balloon will also decrease, the pressure will decrease. Now step 2, this will therefore create a pressure imbalance. The outside pressure of the balloon, as we said just now, is now lesser, it decreases. The inside pressure of the balloon caused by air inside the balloon remain as big as before. So this pressure imbalance means that there is a net force that is from the higher pressure to the lower pressure region. In nature, there's always this rule that whenever there's a higher pressure region and there's a lower pressure region, there will be something moving, and the force will be from the higher pressure to the lower pressure region. So in addition to this example, you can think of wind, formation of wind in jog, where there's a high pressure region to a low pressure region, wind will flow in that particular direction. So therefore, this results in an expansion for the balloon. And lastly, for step 3, now let's shift our focus to what's happening within the balloon itself. So as the balloon starts to expand, the volume inside increases. So this means that the number of air particles per unit volume within the balloon decreases. So the frequency of collision by the air particles on the inner surface area of the balloon, now the inner surface very big already, and the volume very big. So the chances of these air particles, which did not change in numbers inside the balloon, the chances of these air particles hitting the inner wall of the balloon will decrease. So this means that the total force of collision by the air in the balloon on the inner surface of the balloon will decrease, and therefore the pressure of air inside the balloon will therefore decrease. So there's multiple steps here in the reasoning. It's good to pen this down and to go through this step by step, bullet point by bullet point. And in my answer, I have connected the various bullet points in the 3 steps. So once you slow down and reread this again, you should be able to make this connection.